Our final speaker today is Robin Schaefer.
So, welcome Robin, and Robin is from Loxton in South Australia.
Thank you, Jane, and thank you to everyone here today. Well, I'm not sure if I drew the long straw or the short straw to be speaking at the end of the fantastic conference and with a fantastic array of speakers. There's been so much information that's been shared, and you kind of wonder whether perhaps we're running out of information. But one thing is sure, if ever you haven't got anything to talk about, you can always talk about the weather, which is what I'm going to talk about today. So, yeah, my research topic has been weather forecasting and business management systems. I'd like to introduce you to my family, my wife Rebecca, Brianna, Jordan, Caleb, Isaac and Elise. And I'd like to especially thank them for all the support they've given me. It's really been their Nuffield scholarship as well as mine. All of them have all grown as much as I have as I've journeyed around the world. I'd like to thank Nuffield for having confidence in me and in my research topic, something that was pretty new for Nuffield, researching the weather. And I'd like to thank GRDC as well for their financial backing to enable me to do my scholarship. I'd also like to thank fellow Nuffield scholar and business partner, John Gladigo, for holding the ropes together of our business and while I was away, and also my other co-workers and our employees at Bullaborough. So Bullaborough is a collaborative farming business that I'm general manager of. We're located at Loxton in the Northern Valley of South Australia, and we're cropping in one of the driest areas on earth for dryland cropping. Our average rainfall is, annual rainfall is 275 millimetres, and our growing season rainfall is 175 millimetres. About 6 years ago, John did a Nuffield scholarship on collaborative farming, and on his return he approached me and we joined our farming businesses together to form this new collaborative venture. At that stage, each of us were cropping about 2,000 hectares, and now we crop about 8,500 hectares. So in my in researching my scholarship, I travelled to the Netherlands, England, Ireland, Canada, USA, Argentina, New Zealand, and finished up and wrote my report in Fiji, which is in fact nearly every continent on Earth. Visited some really interesting places. The European Centre for Medium Range Forecasting at Reading in the UK is so well known for being one of the lead forecasting places for medium and seasonal forecasting. Also the UK Met Office, which is held in high regard. I visited private weather forecasters such as the WeatherQuest team at Norwich in England. Also in Canada, Ray Garnett, who started off with the Canadian Wheat Board as a crop forecaster, went on to write a number of papers on long lead weather forecasting, and now is recognised for his ability to forecast North American and global wheat crops as a private, in a private way. Travelled south to Oklahoma. Oklahoma has one of the most extreme climates on Earth. They can have snowstorms, heat waves, tornadoes. They've actually developed a live weather recording matrix down there. Well, these weather stations are about 30 kilometres apart on a grid, and it's one of the most intensive ones I've seen in my travels. And you know, measuring everything, every part of the weather, and even soil moisture as well too over the state of Oklahoma. And it's basically to help them to predict extreme weather. From there I went down to Argentina, to the La Pampa region. They have a very variable climate down there as well too. Their rainfall can vary from 400 to 1,000 millimetres from one season to the next. From there across to New Zealand, visited Ken Ring, who uses some rather unusual weather forecasting techniques. Some people would call him a lunatic, but actually, when I actually researched into and spoke to him about the way he does this forecasting, I actually realised there was a lot of scientific evidence to back up what he was doing, and he spoke, like many farmers do, from his own personal experiences as a starting point for his weather forecasting techniques. Many people, well, I've heard people refer to the Bureau of Meteorology as the Bureau of Mythology. And I've even heard people blame them when they blame them for the weather when they've simply forecast the weather for their wedding or something like that. But I think in some respects this is not really warranted. And I'll just have a look at this chart here. It's really interesting to see over the past 30 years, you know, how much weather forecasting has improved. Each one of these trails show show 3, 5, 7 and 10 day forecasts and how much they've improved in the last 30 years. The interesting thing happens here about 2000 where you'll see the plume close up. Now the difference, the top of the plume is the Northern Hemisphere, the bottom of the plume is the Southern Hemisphere. And what happened here was the advent of satellite technology really changed weather forecasting. You can see in the Southern Hemisphere for us, for the 3 day forecast back here in the early 80s, when it went from 70% to now 97%, which is, I think, pretty remarkable, really. Computing power has also been a big driver in improving the weather forecasting. And really this has come about because weather forecasts start with a grid. So the closer the grid, the more computing power is required, because it's not only a two-dimensional grid, it's actually a four-dimensional grid. Because it's two-dimensional and then height for atmosphere, all the different levels, and then plus time as well too. So as computing power's improved, that's improved the forecasting ability. As I said before, satellite technology has also played an important part. And if you look at the reason why, you'll see in the Northern Hemisphere, there's a lot of landmass, a lot of opportunity to have weather recording stations. In the Southern Hemisphere, mostly water. A little bit of land, a little bit of land, a little bit of land, mostly water. So the satellites really help for the starting point for the forecast of what the weather was actually doing at any particular moment. Another thing I learned was about teleconnections. I've never heard of this before, but was introduced to me by Ray Garner. It's actually quite a common term through meteorology. What it actually means is a casual connection or correlation between meteorology or other phenomena that are a long distance apart. So some of the things we've heard about in Australia are El Nino, Southern Oscillation Index, the Indian Ocean Dipole, the Southern Annular Mode. There's actually a whole lot more of these around the world, and a couple of them that I'd never heard of before was the Pacific Decadal Oscillation. And this one actually happens over 20 to 40 years. You know, we see as the ENSO being something that's only, you know, that's yearly, but this is 20 to 40 years. And then there's the Atlantic Multidecadal Oscillation, which happens over 80 to 100 years. The interesting thing for me was, after meeting with Ken Ring, is that how some of these cycles actually match up with the solar and lunar cycles. Another thing that development has been the development of this ensemble forecasting. This has really enabled weather forecasters to provide us with a probability-based forecast. Within the ensemble forecasting, they actually introduce errors into a forecast, and they do this a number of times, and so they end up with, like, the ECMWF uses a 51-member ensemble. So if you look at this here, this is actually a pressure system moving across Europe. And each line is a member of the ensemble and is predicting what will happen to that low pressure system. So you can see we start out, they're all showing pretty similar, but as we get out further, there's a lot more interference, and the errors start to blow out. It makes forecasting a lot more difficult. The question is then, how can we use this? This was shown to me by Jim Bacon of WeatherQuest. This is something he uses for his clients, which shows the spread of probabilities of one of the ensemble forecasts. And here you'll see, for the grower that he was using this for, was temperatures below zero were actually quite critical, because during that time he could cover his crop up to protect it. You'll see here that there's a high probability of the weather dropping below zero, the temperature dropping below 0 degrees for a couple of days here, and also here. But the main probabilities aren't showing up. There's actually a longer period through here where it's still likely that he could have a whole lot of days that are below zero, which will affect the management of his crop. I've had people say to me, weather forecasts, they're no good unless they're going to be 100% accurate. I disagree. I believe that we can actually use weather forecasts. If we know about probability and we know how to use it, that they can actually be quite a usable management tool. I've also had asked, well, what are the best forecasts? Certainly the ECMWF are one of the lead forecasters across the world as far as however, a lot of the information they sell onto onto other institutional forecasters, so it's not readily available to customers. The other thing that I found out is that generally private weather forecasters seem to be more at the cutting edge of long lead forecasting and seasonal forecasting. With our own business, we've been using Ian Holton for a long time, and we've actually seen him improve his reliability over the years. But once again, it's never 100% accurate. But certainly I've been really interested this year to watch some of Ken Ring's forecasts that he supplied to us and some of the accuracy that he's achieving there. Another area that I believe needs further research is micrometeorology. This is something that very little work has been done on around the world. And what we're looking at here is small scale stuff. What happens in 1.5 or less than 1.5 square kilometres, and it really affects some of our work in agriculture, especially spray application and that sort of thing, where it can be really quite critical. Not much work has been done at all around the world on that. So for me, the Nuffield Scholarship has been a real part of my personal growth. It's really challenged me. I remember travelling through Argentina, not being able to speak a word of Spanish, going into a restaurant or cafe to order some lunch, couldn't read the menu, couldn't communicate what I wanted for lunch, so I sort of pointed to what I wanted, and it's amazing, you really get surprised sometimes with what you get dished up. But, for me it's all food, so I enjoyed it and it was part of the experience. I also learnt that it changed my perspective. You know, I didn't think corn would grow that high. I went to the Ukraine thinking it was a developing country, and yet we saw farmers there that were as good as the best farmers in Australia, using the technology that the best farmers in Australia are using. And you know, that's available to them today because of technology, because of mobile phones, because of the internet. So they're certainly a real competitor for us. It also taught me, unlocked many doors for me, and it taught me not necessarily to take things at face value. One of the doors that unlocked, I had the opportunity to have my photo taken with Barack Obama. I won't say any more than that, but if you have a look at my blog, you'll see for yourself. As I travelled around the world and spoke to meteorologists, they all saying the same thing. To their knowledge, a project like this studying AgMet has never been done before. Overall, in my project, I feel like I've really only just scratched the surface. There's so much more out there that could be done, and I would encourage other scholars to perhaps take it on from there. It's really also opened my eyes about the impact of some of these longer term cycles. You know, some of these guys in Argentina could have been farming their whole entire life in above average rainfall climate. When I was in Oklahoma, I was speaking to Chuck Coffey from the Samuel Roberts Noble Foundation. He was telling me that in Oklahoma they had 10 years of above average growing or above average rainfall for them. And everyone was saying this is a new norm, this is climate change, this is where we're farming now. All of a sudden, in the last 2 years, they've gone into drought. And when they've looked at some of these longer term cycles, what they're seeing is that it's just that those 10 good years were just, some of these cycles just happened to line up. And it wasn't actually changing climate, but they were actually moving back to more of an average, more of a longer term average. I think there's real potential there for some of the non-mainstream forecasting techniques to be used within our business as well too. Another thing that was really interesting is, on a personal level, is the, we've seen in our own district, sometimes you'll get weather events moving through, rainfall event, and particular areas will get a more rainfall than other areas. And then what you'll see is through the growing season, for a while, the rainfall will continue to track that area, and so they'll continue to get increased rainfall. And it always challenged me, what's going on here? Is this just like I'm just seeing things or what? But I was actually speaking to a researcher at the at the Oklahoma National Weather Centre, and he said, no, we've actually proved that. And he gave an example where in Oklahoma, where they grow corn, he said that's like where the corn crop ends, it's like a knife edge almost. And he said that when they harvest that corn, he can actually almost tell the week that they finish harvesting the corn, because all of a sudden they'll get thunderstorms forming alongside the line where the corn finishes. And what's happening is the evapotranspiration from the corn is actually causing these thunderstorms. And getting back to how this relates to what I was saying, he's saying that it's actually the convection along the edge of these, of like where the increased rainfall is being received, that's creating rainfall for the following fronts as they come through. So as I finish, I want to leave you with one thing. I think that as we continue on, weather forecasts will become more accurate. But as managers, I think that we need to use them to manage our risk and not to increase our risk. Thank you.